We welcome you here at the Technical Forum at the Group Exhibit Hydrogen and Fuel Cells 2013. Please have a seat, have a free drink. You are really invited to listen to the next presentation. Come here and enjoy with us the next presentation about engineering services to accelerate fuel cells development by Ballard Power Systems, by the Platform Manager Engineering Services, T.J. Lowy. Here we go. A warm welcome for you.
Good afternoon. Thank you for coming. So, engineering services is a relatively new offering from Ballard. We've come to understand that we can leverage our experience and our facilities to help our customers accelerate their time to market and provide services that may not otherwise be available. I'm going to give you a broad overview of the types of engineering services offered by Ballard and how these can be used to help you succeed with fuel cells. I'll provide some examples of the engineering services work we're doing and give an idea of what we can achieve together. At the end of the presentation, I'll be available to answer some questions you may have about Ballard or the services that we provide. Now, before I get into the engineering services in detail, I'll start by telling you a little bit about Ballard Power Systems. Ballard is a recognized leader in proton exchange membrane fuel cells. From our headquarters in Burnaby, British Columbia, we handle the entire engineering cycle for fuel cells. Our stacks are fully designed in-house, including catalyst layer and bipolar plate design. We handle much of our own manufacturing, including coating, laminating, sealing, as well as stack and system assembly. We have our own channels to market and have helped demonstrate customer success with our global customer support and applications engineering. Ballard's current focus is on commercial markets, focusing on near-term commercial opportunities that make sense from a business standpoint today. We have 355 employees around the world and operations in Canada, the United States, Mexico, and Denmark. With a long history of fuel cell research and development, Ballard has a strong intellectual property portfolio covering all aspects of design, materials, processes, and operating strategies. In addition to the 200 patents and applications that Ballard owns, we also license the rights to over 1,000 other patents and applications owned by companies we have worked with in the past. Aside from registered patents, Ballard has a wealth of fundamental understanding covering all aspects of stack operation, testing protocols, system integration, component design, and fuel processing. Through engaging Ballard's engineering services, this wealth of knowledge is made available to customers. Agreements can be structured to allow for ongoing access to necessary IP, ensuring customers can continue their work unimpeded. For years, Ballard worked closely with Daimler, Chrysler, and Ford as part of a vehicular fuel cell alliance. Over the years, Ballard supplied hundreds of stacks to those alliance partners and other automotive OEMs. Through this history, Ballard demonstrated the ability to meet automotive Tier 1 supplier agreements. In simultaneously working with a number of automotive OEMs, Ballard demonstrated that we could ensure the security of customer information. Our automotive technology development program provided a means for significant improvement in a number of areas of fuel cell performance. During automotive development, Ballard achieved reduced cost, enhanced reliability, and improved manufacturability. To meet stretched automotive requirements, Ballard pushed to increase lifetime, develop freestart capability, and move to higher power densities. The know-how gained in automotive can be seen in the fuel cell stack products that Ballard has for sale today. What's more, the quality standards put in place for automotive customers have become a part of Ballard culture and are applied across all products and processes that Ballard offers. Over the years, Ballard supplied over 500 fuel cell products to 9 of the top automotive companies in the world. Earlier this year, restrictions lifted, allowing Ballard to work directly with automotive OEMs once more. As some of you may have heard, we recently started an engineering services program with Volkswagen, which will see significant advantages for both companies. Without the restrictions that have prevented Ballard from working in the automotive sector for the past number of years, we're looking forward to new opportunities to work with automotive OEMs through our engineering services. This is an outline of Ballard's standard product offering and product portfolio, which consists of a number of stacks and systems that are commercially available today, which range in size from small air-cooled stacks in the 500-watt range to multi-megawatt power generating products. Most of our products are geared towards specific applications. At the top left, the FC Gen 1020 ACS air-cooled stack is primarily used for telecom backup, and the Electrogen systems on the bottom left are built around them. That line of telecom backup systems includes units that run on hydrogen and methanol with an onboard reformer. The FC Gen 1300 liquid-cooled stack is a building block for the ClearGen distributed generation power plants. And as I mentioned, they scale from hundreds of kilowatts up to multi-megawatt systems. For materials handling applications, the FC Velocity 9 SSL is a scalable liquid-cooled stack that's available in a number of different power configurations. Typically used in fork truck applications, it can also be used for range extenders and auxiliary power systems. The FC Velocity 1100 is designed for automotive and is also the stack inside our HD6 heavy-duty fuel cell module. The HD6 is available in either 75 or 150 kilowatt options, and aside from powering transit buses in Whistler, BC, Oslo, and Cologne, it can be put to use in locomotive, marine, or industrial applications. Ballard's main facility in Burnaby is our primary product development and manufacturing center. The 5,400 square meter test lab logs over 400,000 hours of testing each year, with the log data automatically being collected, stored, and databased. Test stations in our facility range from under 100 watts to over 300 kilowatts, which include dynamic test stations that can simulate drive cycle or other load cycles, and in some cases have connected environmental chambers which can hold the entire fuel cell system while operating. We have specialized test equipment that can be used to evaluate MEA designs or carry out diagnostics and failure analysis. Burnaby is also home to our fuel cell manufacturing facility. We have coating, sealing, and assembly capability on site with significant automation and room to scale up beyond our current needs. Ballard also has low-cost manufacturing facilities in Mexico and Denmark. Today, these are used to assemble telecom backup systems, but they have the flexibility to be leveraged for other uses. A tour of our Burnaby facility is available during the Hydrogen and Fuel Cells Conference in Vancouver this June, and I'd like to invite any of you planning to come to that conference to sign up for the tour on the conference website. We're very proud of this facility, and we'd love to show it off to everybody. So now I'll get into the core of the presentation about engineering services offering. So we feel that Ballard's Engineering Services provides a high-value way to accelerate fuel cell development efforts. Our team provides tools and technologies for development, optimization, integration, and validation of fuel cell components, stacks, and systems. By engaging Ballard's Engineering Services, your company can take advantage of the high level of competency in a range of specialized activities. The areas shown on this slide are all part of Ballard's Engineering Services, and I'll dig into each one a little bit deeper. So product development, from catalyst layers or plates and other individual stack components to MEAs and unit cells, all the way to complete systems or individual system components. Our applications engineering team is available to help our customers to be successful when they're using Ballard components in their applications. Reference systems are prototype or brass board systems that are built around Ballard stacks, and they greatly accelerate the customer's system development time. Our fuel cell testing services use our own test equipment, protocols, and experience to evaluate fuel cell products in specific applications and scenarios. Ballard can also provide custom fuel cell and fuel cell components manufactured in-house or through our own suppliers. These services are available in conjunction with product development or for customer designs. Our failure analysis techniques and equipment have been used over the years as part of our design and development cycle. We work with customers to understand why their Ballard stacks are not performing as expected, and can also analyze stacks from other manufacturers, pinpointing design issues or failures due to operating conditions or environment. Ballard's design team is backed by a modeling group armed with an array of fuel cell specific models that help drive design. In addition, we have in-house capability to do more standard types of modeling such as FEA and CFD. Most of the test stations in our lab facility were either built or heavily modified by Ballard. We have an internal team dedicated to building and customizing test stations and have made this available to outside customers. So our product development range of services start with full stack, custom stack design, but can also include repackaging of existing designs to new form factors and development of each of the individual components that go into the fuel cell. Some examples may include starting with a standard Ballard stack and developing a new MEA that's specific to the customer requirements. Another option could be providing custom MEAs to a customer to go inside their stack and to fit their existing stack design. And another option would be working with a customer to improve their stack design, including developing and supplying MEAs, plates, or CCM. We also have extensive experience developing system components and can help design subsystems, for example, hydrogen recirculation, humidification, and cathode air supply. So I'd like to show an example of one of the product development projects that we've been doing with Anglo-American Platinum. So this project is really about developing a reformate-capable home generator system for the African market. It'll provide primary electrical power in rural South Africa, where more than 4 million households have no electrical grid connection. Both Ballard and Anglo-American see this as a good opportunity for fuel cells when paired with a reformer technology to provide power with flexible fueling options, where options include propane and natural gas. Ballard does not currently have a fuel cell stack product that was suitable for this application. And so for this project, Ballard is working with Anglo to develop a fuel cell stack that's specific for this application. Applications engineering. Ballard's unique knowledge of PEM fuel cells supports fuel cell stack customers in their system design and integration activities. Applications engineers will start by providing guidance to customers to select the best Ballard product or to determine whether a new product development project is required. Our applications engineering team has helped customers successfully integrate fuel cells into thousands of telecom backup systems, forklift trucks operating around the world, the integration of more than 50 fuel cell buses and many fuel cell cars. After purchasing the stack, the applications engineering team can help with evaluating system stack level trade-offs, understanding the stack and system interactions and interfaces, troubleshooting any issues that come up throughout the design process, advising on material selection suitable for our use with our fuel cells, selecting and sourcing components for the systems, and identifying codes and standards and helping with certification. We feel that Ballard's applications engineering and strong post-sales support are a large part of why Ballard's fuel cell products have been so successful in customers' hands. Onto our reference systems. We've created simple prototype systems that are designed to give customers a starting point for their own system design. These systems, which we refer to as reference systems, reduce development time for a wide variety of stationary and motive power applications by giving customers a head start and reducing the chance of damage during initial design and testing. Reference systems provide a baseline for technology evaluation and can act as a test platform for ongoing system development. Customer can leverage our system design and begin customization for their own applications or their own requirements. These reference systems include the fuel cell stack and the major balance of plant components and controls. The humidification, coolant flow, and temperature control, cathode air supply, and hydrogen recirculation are all included. And they're all coordinated by onboard central controller that comes pre-programmed from Ballard. The components are assembled into a frame and packaged for ease of access and are arranged so that customers can take the components that come with them out and put in custom components to make customizations as needed during their development. In addition to getting the system, we also provide a lot of know-how with the reference systems to ensure that our customers get off to a good start. Customers get an integration and use manual that not only tells them how to use the reference systems, but also gives some background on the rationale behind the design. The control strategy is well documented, so customers understand how the system's controlled, but also have the opportunity to make changes to the control system to meet their specific needs in their own application. Along with that, they receive a P&ID that outline the system and a full BOM with supplier information, so they can recreate or repackage the system to meet their needs, including looking at local supply to get components that are the same as or equivalent to the ones that are provided. Finally, each system is tested in our test facility with a test report provided with it. So currently we have 2 reference systems, one that's built around a 1020 air-cooled stack that has a power of 2.8 kilowatts net, and another that's built around a 9SSL liquid-cooled stack, which has 15 kilowatts net. Depending on customer requirements, we can look at building reference systems around other of our fuel cell offerings. So we feel that we have a world-class test facility. I don't know of anything anywhere else that's dedicated to PEM that comes close. We have the ability to test stacks and stack components. And we've also done performance and durability testing on balance of plant components when used in a hydrogen environment, as we know that things can definitely change when you start testing with hydrogen. We have the ability to carry out cycling with automated dynamic test stations with programmable duty cycles. We do environmental testing, high and low temperature, and a number of environmental chambers that are connected to test stations that also have our dynamic test stations. So we're not just temperature cycling a static stack, we're temperature cycling or running in an environment of low temperature. In addition, we have a number of proprietary accelerated stress test methods, which can be used to evaluate different catalyst or membrane designs, and in some cases accelerate stresses up to 150 times. This reduces test time and allows us to evaluate more design options in a shorter amount of time. We can benchmark stacks and components against published protocols or against our own internal testing protocols. Our test facilities allow us to push operational boundaries and test performance and durability in application-specific operating conditions that fall outside of normal operation. We also have a test engineering group that's dedicated to testing, and we have procedures in place to protect customer technology in our test lab, and also to protect the information on our servers. Using the processes that we adopted while we were working with automotive companies, we use structured problem solving to identify and resolve material and product failure issues. The same analysis tools and know-how we've used over the years to understand stack failures are available to our engineering services customers. This valuable information is fed back to the design process and helps move the design forward. Tools on site at Ballard and available include SEM and optical microscope investigation, catalyst degradation and content analysis, chemical analysis, and understanding of material degradation. Our failure analysis results can be provided as raw data, or it can also be integrated into a full report to the customer. Over the years, Ballard has developed sophisticated in-house modeling capability. This capability can be put to work as input to the design cycle and can significantly reduce design time by reducing the need to build and test design iterations. Performance models predict how the fuel cell will operate under different conditions and are accurate to plus or minus 2% of cell voltage under much of our operating range. Membrane durability and performance degradation models are used to predict time to failure under different load cycles or operating conditions. We have the capability to do flow and thermal analysis in the system stack or inside the unit cell. We do water management modeling in flow fields and in the MEAs. In this category of engineering services, we can provide results of running the model and just give the answers. We can do a complete analysis report or provide customers with the models they can run themselves. And those models can be incorporated into customer system models. We can also develop or refine the models we have according to individual customer requirements. And we often leverage this simulation modeling capability as part of our product development projects. As far as infrastructure and improvement, as we built much of the equipment in our test and manufacturing facility, we utilize this knowledge to help customers who are interested in getting equipment themselves. We can design and build fuel cell test stations for customers with existing designs, those same designs with some modifications, or test stations built to customer specifications. Ranging from simple load bank to high-powered dynamic test stations with an environmental chamber, we have experience with the full range and can provide that to you. We've also provided consultation services for hydrogen infrastructure and lab safety, lab layout, fuel cell, pilot plant layout, and clean room design. We want to work with our customers throughout the entire design cycle. We start by helping to define requirements, explore the available options and develop a solution, and ensure that the plan is executed to your satisfaction with as much or as little involvement with the customer as you'd like. So we feel that Ballard's engineering services provide a high-value way to accelerate your fuel cell development. Our history and experience means a unique range of skill sets that's not easily found in the market, and our unique knowledge of PEM fuel cells and systems integration can enable our customers to create industry-leading clean energy solutions. So this single page summarizes our offering of engineering services. My contact information is there. We're just around the corner at booth D67. I invite you to come talk to us, and if there's any questions, I can answer those now.
Thank you, Mr. Loy, for this very interesting and informative presentation. Are here in the audience any questions right now? Okay.
My name is Mr. Miller. I have one question about the development of your new bus fuel cells. When will you introduce this fuel cell for bus? And during the last weeks, you have closed a great deal with Volkswagen, a German car maker. What's your part in this connection? Thank you.
The fuel cell, our new fuel cell module for bus should be available within the next year. And that'll be leveraging off of our HD6 bus module. And we're looking to basically take that to the next generation. As far as the Volkswagen deal, since that deal was signed, it's basically been brought in to Ballard as a it's run as a project within Ballard that's like a large-scale project because of the scale of that deal. So going forward, that's being treated as a separate project outside of engineering services, but it was brought in underneath the engineering services banner.
Okay. Do here are any other questions right now? So if not, like written here at the flat screen, you have the opportunity to follow Mr. Lyer to his booth here at the group exhibit Hydrogen and Fuel Cells. It's the booth D67. Thank you again very, very much for being here. So thank you, Mr. Lyer. So we will start in a few minutes with another interesting part of the first day here at the group exhibit Hydrogen and Fuel Cells. We call it the Russian Day, and we will start this second part with presentation from plasma beam technologies to produce solid oxide fuel cells from Mr. Alo Sobolyov from the National Research Tomsk Polytechnic University. Please be here, have a seat, have a drink of the house, and we will start in a few seconds.